So we know how to find the volume of cylinders, prisms, cones, spheres. Now we got to figure out what happens when we put them all together into these shapes called composite solids. Well, I have the steps listed for you here, and we're going to go through some problems now. And I'm going to start off by doing one example for you, and then I'm going to have you guys try them on a sheet of lined paper, and then the video will pause and you'll have to put in your answer, and then it'll check it, and then we'll move on, and then you'll have to respond by, after you see how I did it, you'll have to respond with a written explanation of maybe where you went wrong if you got it incorrect. Okay, so that's the process in this video. Problem number one, we're going to start here. First, I just want to let you know that for pi, we're going to use the approximation 3.14. Please use that. Don't press the pi button, because then you'll get a slightly different answer than I did in these problems, okay? And we're going to always round to the nearest tenth. All right? So we'll round to the nearest tenth, and we'll use 3.14 for pi. All right, first problem. This is the example problem. This will help you so you know how to do the other. There's 4 other problems. Okay, let's get started. First, we're going to do step 1, name the shape. Now, in this case, it's shapes. We're going to break it up into 2 shapes, write the appropriate formulas for those 2 shapes, plug in the appropriate dimensions, and follow order of operations to simplify and find your answer. And I have my calculator ready to roll for when I need that, because I know I will. Okay, let's start off with naming the shapes. I have a rectangular prism here that I'm going to start with. So rectangular prism, and then on top of that, I have this beautiful half of a cylinder. Half of a cylinder. So if I have half of a cylinder, half of a cylinder, half of, remember of typically means multiply. So now I just need my formulas for these. Well, a rectangular prism, I know that all prisms have a volume of the area of the base times the height. And in this case, the base is going to be a rectangle. So I'm going to replace that big B with either LW or BH. Basically, I just am going to multiply the dimensions of this base by each other. So that's going to, I'll just do length times width for the B, and then the height is going to be that third dimension that shoots out perpendicular to the base, and that's going to be my height. Okay? Then I'm going to write down my formula for half of a cylinder. I know that a cylinder is pi r squared h, but since I'm just doing half of it, I'm going to slide a half right in there. Half of the regular formula for a cylinder. Now we have to go to we did step 1, we did step 2, we're going to go on to step 3. Plug in the appropriate dimensions. So for this rectangular prism, I'm looking at the area of the base, which would be the bottom shaded in green rectangle down there, and that would be, I can't see now, 50. 25 times 50 would be the area of the base, and then we extend that base to a height of 30. So that's going to give us 25 times 50 times 30. Gives us 37,500. All right, next we're going to go over to this half of a cylinder, and we get half, or we could just type in 0.5. Remember, using the approximation of 3.14, so I should change this to approximately symbol. The radius, okay, that's a little tricky. I'm going to erase some of this to clear out some of the confusion. All right, so this line here is the diameter. So I look at this horizontal line down here, which is 25. So my My diameter is 25, but the formula doesn't ask for diameter, it asks for radius. So we have to cut that in half. 25 cut in half is 12.5, and I have to square that. And then I multiply it by the height, and the height of that cylinder is that dimension there, which we can see down here is the 50. All right, so we're going to multiply that by 50. All right, now I got to multiply all that. So it's going to be 0.5 times 3.14 times 12.5 times 12.5 times 50. Let me just make sure that's right. Everything's in there correctly. Very good. All right, and that's going to be 12,265. 12,265, and then I think it was 0.625. 0.625, yes. All right, and then what do we do after that? We are going to add those two volumes up. Add those two volumes up. So I'm going to add 37,500 to this. So let's add 37,500. And that gives us a grand total, a grand total of 49,765.6, and to the 10th, so the hundredths place says a 2, so that says keep the 10th place the same. So 49,765.6, 49765. 49765.6. And what type of units are we going to use? Cubic units, because we're talking about volume. So centimeters cubed. All right. So far, so good. I hope that made sense to you. Remember, bases in this case could be, it doesn't have to be what it's sitting on. I did what it's sitting on for this bottom part, but really the base of the cylinder is actually that face and that face. So anyway, it's not really relevant, but just telling you so you can make sure that you don't make mistakes. Okay. Here we have another shape, a solid, a composite solid. And what I want you to do is to try it on your own. All right. Break it up into the shapes that you think it is, and you're going to follow the steps for each shape, and then you're going to put in your answer and see if you get it right. And then if you get it wrong, try to find your mistake. All right? Now I'm going to do it myself. Name the shape. We have a rectangular prism, and it looks like I have these are exactly the same, so I'm going to take that rectangular prism and times it by 2. I need my formula for that rectangular prism, which is volume equals the area of the base times the height, or length times width times height. So I get my length of 20 times 8, and then give it a height of 5. So that would be 100, that would be 800. And then I have to times it by 2 since I have 2 of them, so it would be 1,600. All right, now I have my cylinder. This time it is a full cylinder, so volume equals pi r squared h. Volume equals, we're going to use 3.14. Looks like they gave me the diameter, so I have to cut that in half and put it in for the radius. And then my height. Height of a three-dimensional figure always meets the base at a right angle. So that's 15 there. I'm going to ask my calculator to help me. I know that this is 16, so I'll do 3.1. Oops, let's clear that out. 3.14 times 16 times 15, 753.6. 753.6. 753.6. Is that right? Yep, and now we're just going to add his 1600. All right, 0.63532. That's going to be 2,353.6. Oh, I forgot one thing. Need my units. It's going to be meters cubed. Did I put cubed up here? Yes, I did. All right, meters cubed. And on to the next problem. Try to describe what you might have done wrong in this problem and learn from your mistake and then move on. Here we go. Now, this problem might take a little bit of explanation. This has a hole that's in the shape of a cylinder. All right, so it's a cylinder with a cylindrical hole in the middle. So how are we going to do that? Well, let's describe both of those shapes. So let's call it the large cylinder and then the small cylinder. And what are we going to do with those? Are we going to add them up? Are their areas going to be combined to get the total area? No, they're going to be subtracted. So once we get their areas, we're going to subtract them to figure out what the area is of just the outer, like kind of extended donut shape, or I guess you could think of it as a paper towel roll, right, with a hole in the middle. So let's talk about the volume formula. So we did step one, we named the shapes. Check. Now we're going to put our formulas down. We know that the volume of the cylinder is going to be pi r squared h. And so we're going to use 3.14. I keep forgetting to do the approximately symbol. We have, it looks like, is that a, yes, that's a diameter of 4.2. So we're going to plug in a radius of half of that and square it. And then our height is going to be the same height for this big cylinder as the same height for the hole. So that's going to be 26. Definitely going to use my calculator for this. 3.14 times 2.1 times 2.1. What's that other number? Times 26. That gives me 360 and then 0.324. Is that right? All right. So then we're going to move on over here to the small cylinder. I just did the small cylinder. Okay, here. Let's do this. Small and large. There we have it. All right, I'm not too far into this.